Mhm. Hey guys, this is our lesson 9.6 video, and we're going to talk about solving right triangles. So we can use all of our trig functions, sine, cosine, and tangent, to solve every length, every side length, and every angle in a triangle. That's what this is going to be about. So our TP has a little story. If you watch the videos, I don't know if it's in last lesson or if it's attached to this lesson. I forgot already. There's a little video about an Indian tribe and Chief Sokotoa. So here is how to write it out on your paper to help you decide what to use, which trig function to use on each problem. So Sokotoa is how we can remember all of those. Sine for the S is opposite over hypotenuse. Cosine is the C, is adjacent over hypotenuse, and tangent for the T is opposite over adjacent. Okay, so we're going to use trigonometric ratios and solve right triangles, which again means find every side length of a triangle and every measure of an angle. And we're going to do that by finding using inverse tangent. Inverse trigonometric function is abbreviated tan -1 for the acute angle A. If tangent A equals x, then the tangent inverse of A equals the measure of angle A. And you'll see what that means in a minute. We also have the inverse sine and the inverse cosine. So it simply means if we don't know the angle, then we can put our opposite over hypotenuse or the adjacent over hypotenuse or the opposite over adjacent with that trig function, and we can find the measure of the angle. So feel free to pause to write all of this down. All right, and we also are solving a right triangle, which means to find all the unknown side lengths and angle measures of a right angle. All right, so first, let's determine which angle has a cosine of 0.5 or 1/2, right? So it can't be angle C because angle C is our right angle. And so we'll look at either A or B. That's our acute angles. So if we look at angle A, cosine is the adjacent over hypotenuse. And so that would be square root of 3 over 2. And cosine of B is the adjacent 1 over hypotenuse, 2. So our cosine, square root of 3 over 2, you can put it in the calculator and get a decimal. Cosine of B, we get 1/2, which is also 0.5. So our answer is angle B, or the cosine of angle B equals 0.5. Okay, so when we read that tan -1, we say the inverse tangent of x. The inverse tangent of x. So here are the inverse formulas. The inverse tangent, if tangent A equals x, then tan inverse of x equals the measure of angle A. And if sine A equals y, then the inverse sine of y equals the measure of angle A. Inverse cosine, if the cosine of A equals z, then the inverse cosine of z equals the measure of angle A. And if you remember our tangent, sine, and cosine from the previous, we used the side lengths over here. So we would use tan inverse of BC over AC, which is our opposite over hypotenuse, equals the measure of angle A. Okay, so that's another way to write it. Okay, so finding the angle measures. I'm going to move that over a little bit. A, B, and C are acute angle of 3 different triangles. We can use our calculator to find the measures of each angle to the 10th of a degree. So we only want to go to a 10th of a degree. And we're going to hit second and the appropriate trig buttons. So instead of using sine, cosine, and tangent on our calculators, we're going to use those second and then those buttons. So tan of 3/4. Get my calculator here. I'm going to go to the document camera now. Okay, so tangent of 3/4, we're here on our notes, example 2. We're going to hit the second button. I'm going to turn it on first. Yeah, second button, and then tangent. And you'll see on your screen that it brings up tan -1. 3/4, we do 3 divided by 4, and we get to our nearest 10th of a degree, we get 36.9. If you are using the regular calculator, there's a second button on your calculator here, and you'll see those inverse sine, cosine, and tangents come up. So inverse tangent. We're going to do that after we put in our number, right? So 3 divided by 4 equals, and then do your inverse tangent, and you get your same answer. Okay, sine B equals 87 over 100. So we're going to do second sine. So you see your sine inverse come up, and then do 87 divided by 100. And 60.10, so 4/5 goes to 0.5, 60.5. If you're using your other calculator, you want to do 87 divided by 100 equals, and then you have your second button, make sure it's hit before you push the sine inverse button, and you get your same answer. Okay, and then the cosine of C equals 320, so we're going to use the inverse. Using this calculator first, I'm going to do 3 divided by 20 equals, and then your cosine inverse button. So it'll be 81.37 goes to 4. And on your regular calculator, you do second cosine, 3 divided by 20. And you get the same answer. Okay, example 3, I want you to pause the video and see if you can find these answers on your own. When you unpause the video, I'll help you check your answers. Jeopardy theme song. All right, so we do tan inverse, second tan, oops, that didn't work, second tan 43 divided by 100, we get 23.3 degrees. These are all measures of angles, so I should have measured I should have wrote degrees on all of these. All right, then sine inverse. 17 divided by 25. 42.8. And cosine inverse 47 divided by 50. 19.9. Okay. If you're getting different answers, remember you might need to reset your calculator into the degree mode, and you do that by going to mode and finding degree, cursor over it, and push enter. Okay. I'm going to go back to the slideshow now. Okay, to solve a right triangle means you have to find all the unknown side lengths and angle measures. In order to use a trig ratio, you have to know one side length and one angle. So we'll be solving for two side lengths. Oh, so you can use the trig functions knowing either two side lengths or knowing one side length and the measure of one angle, one of the acute angles, not the right triangle. Okay, so you need to know at least two pieces of information to use the trig functions to solve a right triangle. All right, so we're going to solve triangle ABC and round the angle measures to the nearest hundredth. So on our triangle, we have two known numbers on here, the 2 and the 3. The 2 and the 3, we're going to pick an angle to do first, okay? We're given the 2 and the 3. What do we need to solve for? We need to find angle A, angle B, and the side length C, okay? So C is the hypotenuse. We could use Pythagorean theorem to solve for that C. Or we could use trig ratios to find that. That's a choice for you to do, okay? If you use the Pythagorean theorem, we get 2 squared plus 3 squared is 4 plus 9. That's the square root of 13 if we solve for C. Measure of angle A. If we look at A, from here we know the opposite angle and the adjacent angle. So if we know opposite, adjacent, if we look at SOHCAHTOA, you write it down. Okay, I think I'm going to go to the paper now. So C was the square root of 13 because we did 3 squared plus 2 squared. Square root, right? Okay, to find the measure of angle A, from A we know 3, which is the opposite side, and we know the 2, which is the adjacent side. So if we look at our SOHCAHTOA, opposite and adjacent when we were on the T or the tangent. So we're going to look for the tangent of A equals, opposite was 3, adjacent was 2. So to find this angle, I want to use the inverse tangent. So I'm going to put it in my calculator. Second tan 3 divided by 2, A equals, round measures to the nearest hundredth. So we're going to do 56.31 degrees. Okay, now we also need to find the measure of angle B. So if we look at B, now, I know the opposite and the adjacent leg. So opposite and adjacent again mean I'm going to use this tangent, the t. So the tangent of b equals, for b, the opposite is 2 and the adjacent is 3. Then I'll put it in my calculator, come back. Second tan, 2 divided by 3, 33.69. All right, example 5. We're going to solve for triangle DEF. I'm going to round our angle measures to the nearest hundredth here. Okay, so I know 2 side lengths. I don't know the third one. Okay, so you can use Pythagorean theorem if you want. This time around, I'm going to show you how to use the trig functions to find that hypotenuse. Okay, so there's one example on how to find it using the Pythagorean theorem. We'll do another example using trig functions. Okay. Then we also need to find the measure of angle E and the measure of angle D. So order is up to you. I'm just going to start with D because it's first alphabetically, right? So starting with D, my known numbers is this 21, and it's the opposite side. And my other known number is the adjacent, is the adjacent side to D. So we have the O and the A, which means we're going to use the TOA again. So we have tangent of D equals opposite was 21, adjacent was 20. So to find the angle measure, I'm going to use the inverse tangent. Second tan, 21 divided by 20, it's 46.397 makes that go to 40. I should be writing measure of angle D. We'll get technical. All right, and then if I look at measure of angle E, from the known side lengths, I know the opposite is 20, and my adjacent leg is 21. So opposite adjacent again means I'm going to use tangent. Now, you're not always going to use tangent. These are just examples that both happen to be tangent. So tangent of E equals opposite was 20, adjacent was 21. We'll put it in our calculator. Why do I keep doing that? Second tan, 20 divided by 21, 43.60. Okay, now the last piece of information I need to know is our last side length, DE. Now we're going to find it using our trig functions now, okay, instead of our Pythagorean theorem. On these kind of examples, it is best to use Pythagorean theorem so you don't get rounding errors, because with these information here, we had to round it, okay, but it's okay to use them also. All right, so we're going to pick an angle to choose from. I'm just going to pick D because it's first alphabetically. Okay, now this is, I'm going to call it H, the hypotenuse. Okay, so if I can also just pick a side here. From my D, it was A and O here. So, but I want to find the H, so I have to use either the adjacent hypotenuse or I'm going to use the opposite hypotenuse. So you can decide which one you like. I'm just going to use the AH just because that's what I picked. So the AH, A and H go with the C, which means I have to use cosine. of D, that was the angle I picked, right, equals the adjacent was 20 over H. But I know the measure of angle D now. It's 46.40. So I'm going to change that. Okay, now to solve for H, I have to get rid of that fraction by multiplying the H, right? And then I'm going to rewrite that. And then I'll divide both sides by that cosine. And then that cancels, and I solve for H, so I need to put it in my calculator. 20 divided by cosine. Now we know the angle measure, so we're not using the inverse, we're just using cosine, 46.40. So H equals 29.00, that's just 29 degrees, right? Not degrees, because this is a side length, just 29. Woo! Gotta be careful on what we're measuring, right? All right, example 6. We're going to round the angle measures to the nearest 100. Okay, so we need to solve for 2 side lengths now and 1 angle. Okay, I'm going to go ahead and solve for the side lengths first. Okay, so we know the angle. So from here, we want to solve for H. That's our opposite side. And the other known number we have is this hypotenuse here. So we have the O and the H. And if we write SOHCAHTOA again, the O and the H, opposite hypotenuse goes with the S, so that's the sine. My angle was 25 equals opposite is H, hypotenuse was 13. Okay, so cancel the fraction by multiplying on both sides. And I have H by itself, so I need to multiply 13 times the sine of 25. And I get 5.49. Okay, now to find G, this is 25 is still my known angle. So with my known angle, G is the adjacent side, and the other known or given value was the hypotenuse. So I have adjacent and hypotenuse. Adjacent and hypotenuse goes with the C, so I'll need to use the cosine. Angle was 25, adjacent was G, and my hypotenuse was 13. Then I solve by multiplying 13 on both sides. G is by itself now, so I can multiply in my calculator. I get G equals 11.78. Okay, so now I know all my side lengths, but I don't know what the measure of angle G is. So if I look at measure of angle G, I can pick what I want to use. Okay, so I definitely want to use the known values here. Okay, now I can't use the angle to find another angle. I have to use side lengths to find the other angle. So we'll definitely use the hypotenuse, and then we can pick, do we want to use the opposite or adjacent? So we have to use the hypotenuse. We use either cosine or sine to set up a function for g. I'm just going to pick the h, sorry, not the O, the h. So if I pick h from the g, that is the adjacent side. It's right next to it, right? So I have adjacent and hypotenuse, which means I'm going to have to use a over h was the ca. So we're going to use the cosine of g equals the adjacent is the h and the hypotenuse is 13. But we know h. H is now 5.49. Okay, so we know both of those legs, and we're to find that angle measure, we can use the cosine inverse of 5.49 over 13. So second cosine, 5.49 divided by 13, and we get 65.019 makes that a 2. And that one is an angle, so we're going to put a degree mark on it. Measure of angle G. There we go. We solve for the rest of our triangle. All right, last example. So our school is building a raked stage, a stage that slants upward from the front to the back to give the audience a better view. The stage will be 30 feet long from front to back with a total rise of 2 feet. You want the rake or the angle of elevation to be 5 degrees or less for safety. Yeah, we don't want people tumbling off that stage. Is the rake stage within your desired range? So we want to see if this angle is 5 degrees or less. Okay. We know the hypotenuse, it's the length of the stage, right? And we know how much it's raised, which is the 2. So from this angle, right across, that's the opposite angle, or opposite side, sorry. And we know the length of the stage is 30. That's the hypotenuse. Sorry, I don't know if you can see that. Okay, so if we have opposite and hypotenuse, that's our so. So we're using sine. X is the angle. Opposite is 2. Hypotenuse is 30. So to find that angle, we are going to have to use the inverse 2 over 30. So second sine 2 divided by 30. Our angle, the measure of angle X equals 3.82. So is it 5 degrees or less? That meets our safety mark. Yes, it is. We did good, right? All right. All right, last thing. See, here's the picture on my shirt that I wanted to wear yesterday. Next week, you'll have your 3 big ideas assignments this week due on Monday. Okay, and next week, that next Monday, you will get your review. You'll have a Chapter 9 vocab test and a Chapter 9 test next week. Read the info on Google Classroom on the stream. It says look at the blueprint. It'll give you more instructions on how tests are going to work while we're on our virtual learning experience together. Hey, if you have any questions, please feel free to join Zoom. email me, text me on Remind, comment on this assignment. There's lots of ways to get in touch. Please keep in touch, and I look forward to hearing from you.